In section 6.7, we're going to learn how to solve equations using the zero product rule. And so that's just basically a fancy way of saying we're going to take our knowledge of factoring that we have learned in this module and use those to solve equations. Basically, we're going to factor equations and set them equal to zero and solve for the variable. There are two different types of equations that we're going to look at. We're going to look at linear equations, or maybe that's what we're used to as linear equations. And the equations that we're going to solve in this section are quadratic equations. So what's the difference? A quadratic equation is a second degree polynomial with just one variable in it. So if we're looking at exercises 1 through 3, let's identify these equations as linear, quadratic, or neither. Number 1 is a quadratic because we can see that our highest degree right here is 2. So the quadratics, you'll see a squared as your highest exponent for your variables. On number 2 over here, we have a linear equation because this x, first of all, it's the only variable, and it has a power of 1. So when your highest power is just 1, then you have a linear equation. On number 3, notice that our highest power is 4. So if the highest power is 2, it's a quadratic. If the highest power is 1, it's linear. But that's neither 1 or 2, right? That's 4. So our answer to number 3 is linear. The zero product rule is really fun to me because it sounds sort of fancy, but it's super simple. If you'll just look right here in the box, the zero product rule says if you have an AB, so that's saying A times B, something times something, 2 factors, and they're equal to 0, then you can separate them. A equals 0 or B equals 0, okay? So let's try this out on number 4. I'm going to say that x minus 3 equals 0 and x plus 8 equals 0. So now I can solve it and add 3 to both sides right here to get that x equals 3. And subtract 8 from both sides right there to get that x equals negative 8. So x equals 3 and negative 8. So on number 5, I can separate both of those factors, set them both equal to 0, and just solve for the variable in each one. So I get 1 equals 2x, then just divide by 2, x equals 1/2. So our two answers is 1/2 and negative 5/4. So on number 6, we have 3 times x minus 6 times 3x plus 1 as factors. And I'm going to set each of those equal to 0. So 3 equals 0. When I go to solve that, I can't because it's a false statement. 3 equals 0, that's not true. So we won't use that, okay? But x minus 6, I can solve. Just add 6 to both sides. So x equals 6. And 3x plus 1. So we move the 1 over, it becomes negative 1, and we divide by 3. So our two answers are x equals 6 and negative 1/3. On number 7, notice that x out front is out front because it's probably a GCF, much like on number 6, the 3 was out front, okay? But I'm still going to set all the factors equal to 0, so x equals 0, and 5x minus 9 equals 0. And now earlier when we said 3 equals 0, that was a false statement, right? But a variable x can equal 0. So this answer right here is good, okay? And over here, 5x minus 9, you're going to add the 9 to both sides. 5x equals 9, so x equals 9 over 5. Our two answers are 0 and 9 over 5. So we just learned that when we have two factors or more factors set equal to 0, that we can separate those out, set them both equal to 0, and solve each equation. Well, this it's not factored, is it? B squared plus 3b minus 40. But I can factor it. We've learned how to factor in the sections before this. So the factors that multiply to give me a negative 40, but that add to give me a positive 3. If you're multiplying to get a negative, then your signs are different. And if we're adding to get a positive 3, then our larger number will be positive. The smaller factor will be negative. So let's look at the factors of 40. So I'll make my larger number positive and the smaller numbers negative, and see if any of these add to give me a positive 3. And these two options right here do. So that would factor into b plus 8 times b minus 5 equals 0. And now I can just say that b plus 8 equals 0 and b minus 5 equals 0. So that b equals negative 8 and b equals 5. On number 9, we're going to try to factor c squared minus 4c plus 3 equals 0. And then we can solve that by, once we factor it, by setting both factors equal to 0. So the factors that multiply to give me a positive 3, but that add to give me a negative 4. Well, if you're multiplying to get a positive, your signs are the same, so either both positive or both negative. But since you're adding to get a negative 4, they'll both be negative. So things that multiply to give me 3, 1 and 3, if I make them both negative, they would multiply to give me a positive 3, and they would add to give me a negative 4. So c minus 3 and c minus 1. And I'm going to set both of those equal to 0. So here's my two answers. On number 10, we still need to use the zero product rule. Problem is, it's not set equal to 0, but we can fix that. Just move the 15 over. So now to factor this trinomial, I'm going to use the AC rule. I'm going to multiply 4 and negative 15 together to get negative 60. So that means I need to find two things that multiply to give me negative 60, but that add to give me a negative 17. If you're multiplying to get a negative, your signs are different, and if you're adding them together to get a negative, your larger number will be negative. So let's write down the factors of 60. So now I'm going to make the larger numbers negative and see if any of these add to give me a negative 17. And I'll be honest with you, my eye is going to the 5 and the 12 and the negative 12, but that's not it. You gotta really think through these. 5 and negative 12 would add to give you negative 7. If we look at the 3 and the negative 20, that's going to be what adds to give you the negative 17. So let's rewrite the original trinomial. So by splitting this up into 3r and negative 20r, I mean, if you add that together, that's negative 17r, right? Well, anyway, I've split that up, and now it's no longer a trinomial. It's a 4-term polynomial, and I can factor that by grouping. So I've grouped the front and the back. In this first binomial, I'm going to pull out a GCF for r squared plus 3r. I'm going to pull out a GCF of r and be left with 4r plus 3. And in the second binomial of negative 20r and negative 15, first of all, that 20, it's negative, right? So that leading coefficient is negative. I'm going to pull out a negative. And 20r and 15. 20 and 15 have a 5 in common. So if you pull that out as your GCF and divide that out, you are left with, okay, so negative 20r divided by negative 5 is 4r, and negative 15 divided by negative 5 is a positive 3. So notice what we're left with on both sides. The inside is now 4r plus 3. If you factor that out, literally factor it out, what are you left with? You're left with r minus 5. So now we're fully factored, and we can set both factors equal to 0. To get an answer of r equals negative 3 over 4 and 5. On number 11, it's already set equal to 0 for us. So that's great. All we have to do is factor it. And we have a binomial this time. It's not a trinomial. So with a binomial, remember you have 3 formulas. You have, just abbreviated, you have the difference of squares, difference of cubes, and the sum of cubes. Well, let's appreciate the names of those, right? A difference would be a minus sign. So we're obviously dealing with a difference formula here. And squares or cubes, well, I see x squared. So let's see if it could be the difference of squares formula, which says if you have an a squared minus a b squared, you will factor that into a plus b and a minus b. So the square root of 25 is 5. The square root of x squared is x. And the square root of 36 is 6. So yes, it fit that difference of squares formula. And now I'm just going to set that equal to 0. So just solve for x. We can subtract 6 from both sides and get that 5x equals negative 6. You can divide both sides by 5 to get that x equals negative 6 over 5. And over here, you're adding 6 to both sides. So 5x equals 6, so x equals positive 6 over 5. For an answer of x equals negative 6 over 5 and 6 over 5. On number 12, it's already set equal to 0, so that's a good thing. But now remember, when we're factoring, it's always just a rule of thumb that you need to factor out the GCF first, or at least look for a GCF. And this trinomial looks like it has a GCF of 3. So I'm going to pull a 3 out. And when I divide everything by 3, I'm left with t squared minus 6t minus 16. So I'm looking for the factors, the two numbers that multiply to give me negative 16, but that would add to give me a negative 6. Well, if you're multiplying to get a negative 16, your signs are different. If you're adding to get a negative 6, that means your larger number is going to be negative and your smaller number is going to be positive. So to multiply to get negative 16, I chose negative 8 and negative 2. Negative 8 and positive 2, because those two numbers would add to give me that negative 6. So now I can just set each factor equal to 0. So on that 3, when I set it equal to 0, that's a false statement. 3 does not equal 0. A number other than 0 cannot equal 0. Now, if I had a variable with it, yeah, we could solve it. But as it is, it's a false statement. And then t minus 8 equals 0, t plus 2 equals 0. You get 8 and negative 2 as your answers for t. On number 14, looks like we're dealing with a binomial. But we need to look and see if there's a GCF first. X cubed minus 81x. Notice I said x both times, so pull out your lowest power, which is x to the first. You would be left with x squared minus 81. For binomials, you have three formulas: difference of squares, difference of cubes, sum of cubes. This looks to be a difference, so it's not going to be sum of cubes. I see a squared symbol, so it's not going to be a difference of cubes. Probably going to be a difference of squares. Let me see if I can take the square root of the front and the back. The square root of x squared is x. The square root of 81 is 9. And don't forget your GCF of x that we pulled out. So now I'm going to set each factor equal to 0. Okay, so we have x equals 0, x plus 9 equals 0, and x minus 9 equals 0. X can equal 0. It's a variable. It's already solved. So that's one of our answers. Then we get negative 9 and positive 9. By the way, the 0, the negative 9, the positive 9, the way I've written it, it's not in any particular order. It's just kind of the order I wrote it down. You could have written it as 9, 0, negative 9. That doesn't matter, so don't get hung up on things like that. Number 15 I'm wanting to solve, but it's not set equal to 0. So that's a red flag, right? But I can set it equal to 0 fairly simply. I can just subtract 4 from both sides. And now I'm going to look for a GCF. There's not one. Think of your three formulas: difference of squares, difference of cubes, sum of cubes. This is not a sum, it's a difference. And it looks like I'm dealing with squares, not cubes. So plus, minus, take the square root of the front and the back. Square root of 9 is 3. Square root of m squared is m. Square root of 4 is 2. So set both factors equal to 0. So I'm going to subtract 2 from both sides and get that 3m equals negative 2, so that then I can divide by 3. Add 2 to both sides. Divide by 3. So m equals negative 2/3 and 2/3. On number 16, we're not set equal to 0, but I can move some things around. I can simplify it and then set it equal to 0. So distribute that negative sign. Give it to the x and the negative 3 so that it changes signs. And then we distribute the 2 to get 2x plus 2. And on that left side, I can combine like terms. 6x minus x is 5x plus 3 equals 2x plus 2. And actually, this is a linear equation. This is not a quadratic, because a quadratic is going to have a squared in it, right? So this linear equation, I'm not going to end up factoring. I can just work it the way we've always solved linear equations. I get 3x plus 3 equals 2. And now I'm going to subtract 3 from both sides to get that negative 1 equals 3x. Divide by 3, x equals negative 1/3. On number 17, it's not set equal to 0, but let's simplify it out. I can't simply move the 5 over yet because the left side is not simplified. I need to distribute the d. So that would be 3d squared plus 14d equals 5. And so now I can subtract 5 from both sides. And we can use that AC method of factoring to look for two things that multiply to give us a negative 15 but add to give us a 14. If you're multiplying to get a negative 15, a negative means your signs must be different, but if you're adding to get a positive 14, then your larger number must be positive and your smaller number must be negative. So 15, 1 and 15, if we made the 15 positive and the 1 negative, they would add to give us 14. So let's rewrite that 14d as plus 15d minus 1d minus 5. And we can factor by grouping, group that front, group the back. In the front, there is a GCF of 3d. You're left with, when you divide 3d squared by 3d, you get just d. When you say 15d divided by 3d, you get 5. On negative 1d minus 5, do notice that leading coefficient, negative 1, is negative, so you want to factor out a negative. But other than that, 1d and 5 don't have anything in common. So just factor out that negative, meaning pretty much we'll just change the signs. Notice what we're left with in both cases is d plus 5. So if we pull that out, we're left with 3d, a minus sign, and we can just say 1. We must now solve, so set both factors equal to 0. We get d equals negative 5, and add 1 to both sides, divide by 3, and you have d equals 1/3. So negative 5 and 1/3. On number 18, it's not set equal to 0, but I can go ahead and move the 3x squared this time because that left side is simplified. So I would get something to the tune of 2x cubed minus 3x squared minus 5x. Notice how I'm putting those in descending order. They need to be in descending order. Now I'm going to look to see if there is a GCF. There's a GCF of x, so that you would be left with 2x squared minus 3x minus 5. So on that trinomial that is left, I'm going to do that AC method. So you're looking for what multiplies to give you negative 10 and what adds to give you negative 3. If you're multiplying to get negative 10, your signs are different. And if you're adding to get a negative, as in negative 3, your larger number will be negative. So the factors of 10, 1 and 10, 2 and 5, 5 and 2, we said the largest number will be negative. So does anything add to give us negative 3? Yes, 2 and negative 5, or negative 5 and 2, whichever way you want to think about it. So let's rewrite that negative 3x as plus 2x minus 5x minus 5. we can group the front and the back together. And in the front, we have a GCF of 2x. We're left with x plus 1. In the back, the leading coefficient is negative. Pull out a negative. And actually, we can also pull out a 5. So we would be left with x plus 1. In both cases, I was left with x plus 1. So if you pull that out, you're left with 2x minus 5. You had a GCF of x. So now if we set all three factors equal to 0, right here, you're going to add 5 to both sides. 2x equals 5 divided by 2, x equals 5 halves. And x equals negative 1. X equals 0 does work, that is true. So x equals 0, negative 1, and 5 halves. Here's a little hint. Whatever the highest degree, as in this time it was 3. So this wasn't a quadratic either. This is a cubic. Anyway, whatever your highest degree is, that's how many answers you're going to have. So let's go test that. Do I have 3 answers? Yes, I do. Okay. Number 19 is not set equal to 0. But before I start moving things over, each side of that equal sign needs to be simplified. And on that left side, I need to clear the parentheses. So I distribute that 6 to both of those. So now I can set it equal to 0. I'm going to move that right side over and say 6a squared plus 12 minus 25a plus 2 equals 0. Combine your like terms. So 12 and 2 is 14. Okay, so let's see. The first thing we're going to do as far as factoring goes is look for a GCF. And I was thinking I was going to be able to pull out a 2, but that's not the case. So now I'm going to use that AC method. And I'm going to look for what multiplies to give me 84 and what adds to give me negative 25. Well, if it's a positive 84, when you multiply to get a positive, your signs are the same. But now if you're adding to get a negative, then both signs will be negative. And this is a rare case, and I say rare, it does happen, but 6 and 14 multiplied to give me 84. And if I were to make them both negative, they would add to give me that negative 25 that I need. So let's rewrite that middle as minus 6a and minus 14a. So now that I have a 4-term polynomial, I would usually just go ahead and group, but just scanning over that 4-term polynomial, the whole thing has a GCF of 2. So factor that out. And now 3a squared minus 3a, group that, and group the 7a and the 7. And in the front, you can pull out a 3a and be left with a minus 1. In the back, and that parenthesis was really supposed to be right there. In the back, you can pull out a negative because of the leading coefficient being negative, and a 7 and be left with a minus 1. In both cases, you were left with a minus 1. And if you pull that out, you're left with 3a minus 7. And don't forget your GCF of 2. we're going to set all the factors equal to 0. That's not a true statement. And over here, move the 7 over, divide by 3. So A equals 1 and 7/3. Number 20 is a 4-term polynomial, and it's set equal to 0, so I'm just going to try to group it. In the front, I can pull out an s squared and be left with 3s plus 1. And in the back, the leading coefficient is negative 12. Pull out a negative, and 12 and 4 have a 4 in common. So if I say negative 12s divided by negative 4, I get 3s. And if I say negative 4 divided by negative 4, I get positive 1. So in both cases, I was left with 3s plus 1. So if we pull that out, I'm left with s squared minus 4. Okay, and you're thinking, oh, can I go ahead and set both factors equal to 0? Well, s squared minus 4, notice it has a squared in it. That's a difference of squares. Square root of s squared is s, square root of 4 is 2. So I can set all 3 factors equal to 0. Divide by 3. And the next 2, s equals negative 2, s equals 2. So s equals negative 1/3, negative 2, and 2. Number 21 is not set equal to 0. But before you go moving that 3 over, before you go moving anything over, each side has to be simplified. And k plus 5 and k plus 7 are not simplified. They are factors. And some of you may be wanting to do k plus 5 equals 3 and k plus 7 equals 3. Can't do that. If it's set equal to 0, you set both factors equal to 0. But if it's set equal to anything else, you can't split it apart like that. So k plus 5, k plus 7, I need to FOIL. That would give me k squared. K times 7 is 7k. 5 times k is 5k. 5 times 7 is 35. And then 35 minus 3 is 32. So now the factors that multiply to give you 32, which is positive, so they'll have the same sign, and that add to give you 12, which is positive. So if you're adding to get a positive, they're both going to be positive. Let's see, 4 and 8. Set both factors equal to 0. You get that k equals -4 and -8.